Cool. So, hello everyone, and first of all, welcome to all our community members for the community meetup on the LocalStack 1.0 general availability. And we are so glad to have pushed forward the release nearly 5 years after the initial inception of LocalStack, which started as a AWS emulator, and now we are the leading innovator in enabling developer teams so that they can just develop and test your cloud applications locally and across your CI/CD pipelines. So we are just organizing this community meetup with all our users, customers, and community members so that we can just walk you through how LocalStack has changed as a product and also as a project, and the steps that we have taken to provide a comprehensive ecosystem of local AWS services, integrations, and tools so that we can make the cloud development experience a breeze for you. Cool. So moving further, we will be recording this meetup so that we can put this over our YouTube channel. If you have not subscribed that, I guess it's the best time to do that. I'll just share the YouTube link during the midway of this session. And you will also find you can just go ahead and you can subscribe to it. And we would greatly appreciate all the efforts to help us reach the first 100 subscribers. So we will do a quick round of intros for everyone who will be presenting today, and we will also get to know about our audience and their respective backgrounds. We will be using Slido primarily for this purpose, and we will further use it for our Q&A as well. Next, we are going to have a short community presentation by Jim, who will be presenting his insights on how LocalStack works with continuous integration pipelines, specifically drone CI. Next, we will be moving to discussing about LocalStack 1.0, checking out all our new features and enhancements, and further, we will move into the tech demos. Lastly, I'm going to discuss a bit about the community efforts that we are putting here at LocalStack, how we have been progressing, and how you can be a part of it. So, yeah, just a round of intros. Hi, my name is Harsh, and I'm the Developer Relations Engineer at LocalStack. I will be moderating today's community meetup, and I will also be organizing further community meetups in the future as well. So just stay tuned to our upcoming events. We have Gerda with us, who is our Chief Operating Officer. She will be discussing about the LocalStack 1.0 GA, and she will be further talking about the product tires. We have Thomas here with us, who is an engineering lead, and he will be talking about the tech demos, the release process in LocalStack, and how his efforts, and along with the whole engineering team effort, has simplified LocalStack as a whole. And finally, we have Waldemar, who is our Chief Technology Officer. He will be talking a lot about the new features. He will be talking a bit about the tech demos and more of them. And yes, we have our LocalStack community hero. We have Jim with us. He's a developer relations engineer at Harness, and he will be talking about testing Terraform AWS modules in drone CI pipelines with LocalStack. So hi, Jim. And first of all, thanks for participating with us.
Hi. Hey, Harsh. Thanks very much for having me. It's great.
My pleasure. Yep. And now we can just jump on the community talk by Jim. So Jim, over to you. You're completely free to share your screen and just walk through the entire stuff that you've prepared for us.
Awesome. Thanks a lot, Harsh. Yeah. Again, it's great to be here. Very privileged to be here. All right, let's see if my share comes through. All right. Looking good? My sharing?
Definitely
Yep,
good.
looks good, Jim.
Awesome. Thanks. Cool. So this is a slight variation on a talk that I gave in June in Amsterdam at HashiConf. And yeah, testing Terraform AWS modules with drone using LocalStack. So yeah, my name is Jim. I'm a senior developer advocate at Harness. I've been a drone user and contributor since 2018. And here's a few ways you can get in touch with me if you want. I live in the US, about a couple hours north of Boston. If you've never heard of Harness, we're a software as a service company. We provide services for every step in the software delivery lifecycle. So from CI to CD, all the way into production with tools like feature flags, cloud cost management, and we're always adding new modules. So this presentation covers 4 areas. So Terraform, the big one, AWS, specifically the Terraform AWS provider, LocalStack, of course. I've got the old logo. I didn't have time to update it. I got to do that. So that will create the testing environment and handle the API interactions in place of AWS. And of course, there's free and paid versions of a LocalStack. What I'm going to show works just fine with the free version. And finally, Drone, which is a container native open source continuous integration tool that was started in 2012. Drone has over 25,000 stars on GitHub. And yeah, so it's quite popular. Harness acquired Drone in 2020. So I'll be sharing how to use Drone to test Terraform resources, terraformed AWS resources against LocalStack in CI. So this is a LocalStack event. I'm sure that you're interested in LocalStack, but even if you don't use Terraform or AWS, hopefully this will get you interested in using LocalStack in your CI pipelines using Drone or a similar CI tool. So that last slide showed some of the tools we'll be using, but not how we'll run tests that will actually exercise things. So I'll be showing two different methods. So the first is Terraform itself. So Terraform actually has a test subcommand in the Terraform CLI built in since version 0.15. And these tests are written in HCL, same Terraform syntax that you already be familiar with. And it is still considered experimental. It's not a official feature, so things might change with this capability. And I'll also show TerraTest, which has been around for a few years now. It was developed or is developed by Gruntwork, and those tests are written in Go. There is a new way to do this that I didn't have time to update this talk around, but in Terraform 1.2, announced at HashiConf, there's now lifecycle pre and post conditions that you can define directly in your resources, which would run every time you run a Terraform apply, not just during test runs. So that is some pretty cool new capability in Terraform that unfortunately I can't show because I didn't have time. So I put together an example repository to go over these capabilities. So this is a Terraform AWS networking module. So it brings up a VPC, sets up public and private subnets, all the kind of things you would need in a VPC in AWS. So the first files, of course, are the files to do with the Terraform module itself, all the .tf files at the root. And for the tests for the Terraform CLI, what those read, I will jump into my VS Code and show that. So beneath the test directory, there's an example directory. In there, there's a test.tf file. So the nice thing about this way of using, when you use the Terraform CLI directly, it has this testing capability built in. It doesn't have to download any extra dependencies, but you do have to define the provider explicitly this way. Once you do that, then you can start defining tests. So when this runs, of course, it actually terraforms the module, which is up at 2 levels. It's a relative path. It passes the required variables. And then here's where you would actually run your tests. So we can check against things like making sure that the VPC ID begins with VPC dash. It's in AWS, all VPCs should start with that, so that should never fail. We can also do things like check that a name tag, like a tag on a resource matches an expected name, and that's this here. So the next piece is what TerraTest would read. So that is this Go file here. So you'll see similar configuration here, same parameters being passed as variables, and the same tests are running to make sure that VPC starts with the desired prefix and that the name tag has what we expect. So LocalStack, where does LocalStack come in? So that's what this file is for. So when you're using LocalStack with the Terraform AWS provider, you tell the provider, don't talk to AWS, talk to LocalStack. And I have LocalStack running in Drone at this address when the Drone pipeline runs. So you do have to pass some settings that turn off some security that you would never turn off normally, but in a CI pipeline, it makes sense. Validation checks, certificate checks, that kind of thing. And then you override your endpoints. So here, I think I only need to be overriding EC2 for what I'm doing. I just left all these in here as an example of all the other endpoints that you can override, and I'm sure there's more that I don't have. So hopefully that's shows. So this file has to be copied into place to override the provider, the AWS provider behavior when the pipeline runs. And then finally, the drone pipeline itself is here, at the root.drone.yml. So I have 2 stages in this pipeline, one per test. So one for Terra test, and then down here, the other one for the Terraform CLI. So LocalStack is right here as a service. So services are, everything's a Docker container. So LocalStack comes up as a service and it runs for the duration of the pipeline. Every step that runs in the pipeline can access LocalStack from the local Docker networking. The first step I have waits for LocalStack to become healthy before continuing, and then the tests run. This is Terra test, so it's a Go based test, so that's running there. This looks very similar to that first stage up until this step here, which runs Terraform test instead. All right, so let's quickly see what this would look like for real. Here's my repository, and if I go in and make a change and trigger a pipeline, here's that the test that I was showing. It's making sure that this variable matches the input variable that was passed for the tag name. So if I change this, it's going to break. So I'll show how this would break if I change that tag. So that looks right. Break the tests, and we'll do this in a PR. So this will trigger my drone pipeline. I can jump into that. So here's my 2 stages running in parallel, the way that I've configured them. LocalStack's here. It's coming up. And then my step that's waiting for it to be healthy, it's already passed because LocalStack comes up pretty quickly. And all the output from LocalStack you'd see here. See how it's running continuously, even though other following steps are completing and going on. LocalStack's going to hang out because it's a service. I wish the UI was clearer, which was a service and which wasn't, or which was a normal step. It's not, other than that you can see that the duration, it will be longer. It will stay for the duration of the pipeline, and you'll see it's the longest duration time, whereas following steps will come and go. So that's really the only way you can see. I wish that was a little clearer, but the tests are running now. So Terra test is here. If you've ever seen a Terra test run, it downloads a lot of Go module dependencies. I could be doing some dependency caching here to speed this up, but I just kept it a bit simple for this demo. Here's the Terraform CLI test that's running. Everything's the same. It's already finished and failed because the test failed as I expected. So that's an advantage of this method of testing using the Terraform CLI itself, is you don't have to download any dependencies. Yeah, it's a nice way of doing Terraform tests. And it doesn't give you much output though. It's very minimal. This Terra test gives you far more output. You'll see the entire plan output, apply, the test run. This is the test failure here. And then when Terra test destroys all the resources, you'll see everything go away here. So this will fail. Oh, there it goes. It failed. Yeah, so that gives you an idea of what the pipelines look like. What's nice about this, really nice about LocalStack, is if these tests fail, if something goes wrong in the tests that you wouldn't have expected, maybe some networking issue, something goes wrong, and you leave orphaned resources, doesn't matter because everything's getting cleaned up by the pipeline, right? All those Docker containers, including LocalStack, gets torn down. You're not left with some stray AWS resources that are going to cost you, money, and you don't have to worry about that if you use LocalStack. So I ran this test a bunch of times using actual AWS resources to see what the difference in time would be. And it was kind of fun to see the results. So this graph shows those same 2 tests that I just shared that went against LocalStack, and then another 2 tests that actually brought up AWS resources. So you can see The difference is quite dramatic. When you bring up AWS resources, sometimes they take over 6 minutes in this case, whereas the local stack-based tests were all very consistent and predictable at less than a minute most of the time, or 2 minutes in case of the Terratest test. So yeah, definitely a good illustration of how much time you can save your developers in tests. So that's pretty much it. We have some resources if you'd like to get involved with our community. We have a community in Slack, in Discourse, community.harness.io. We also have our own meetups that you can potentially join if you're interested. All the documentation for Drone is at docs.drone.io. And LocalStack has some documentation on how to use Drone at the address at the bottom. And with that, I'll say thank you very much for having me. And here again are a few ways to get in touch with me. Thank you very much.
Thanks a lot,
Awesome.
Jim.
Thanks a lot, Jim. This was a really great talk, and it's really good to see insights on, first of all, how LocalStack works together with Terraform, AWS, and Drone CI. Really impressive results that you showed there, and we really love to see how such real-world use cases really plan out and share them with the community. So in the future, we would also love to see way more community contributions and people from the community really sharing their use cases with the broader audience, so we can really learn all from each other. So really, really cool. Can I maybe ask Thomas or Harsh to share my 2 slides, because I'm currently having some sharing issues.
Sure.
So,
By the way, Jim, you have a question from the community. Let me just share that really quick.
Sure.
Yep. So Jim, in your demo, is Drone running locally or in the cloud? Is it possible to run Drone locally on your laptop or PC?
It was running in an instance that we have that we're running ourselves for Harness engineers and developers. But yes, you can run it on your laptop. It is a self-hosted thing. There is not a software as a cloud service at the moment. But yes, it is possible to run it locally. I can share some links. What would be a good place? I could go into Slack maybe, or in here.
You can share this on the Google Meet chat.
Okay, I'll do that.
Sure. I guess there is a question that we can take up right now itself, and it's what's the ideal way to convince your colleagues about LocalStack?
Yeah, I think giving them real metrics on the amount of time that's potentially saved. I really like just talking about the potential of cloud cost savings, the things that you could end up having to pay for if your tests go wrong, or if something unexpected happens. That risk is very real, but in LocalStack that risk is not there, right? So that's pretty easy sell, I would say.
Awesome. Cool. So Greta, yeah, I guess I can hand it over to you.
awesome. Thanks a lot, Harsh. Yeah, so as I said, in general, we really want to focus these community sessions on having a lot of community contributions, like the talk from Jim just now. In this session, we will also focus on our big V1 release. So we have reached this very big milestone of ours, for which we've been working now actually a couple of years. So if we go to the next slide, I just want to give a very brief introduction and history about the project and the company LocalStack and our current growth journey. So basically, we really started LocalStack already back in August 2016, where the very first line of code was committed to our repository. And then it actually took us around 3 more years before we saw like traction going up over time more and more. We really realized that we wanted to build a community around this. So in August 2019, we also launched our LocalStack community in Slack, where we have a lot of people interacting and asking us questions about the product, which we have been growing over time more and more. So as you can see from from now, and if you've been with the project for longer, with the V1 release, we've also changed our entire branding. So we have a new logo now, meaning that we also have some cool LocalStack swag. So there will definitely be some opportunities for the community to engage and also win some swag with our new branding. So I'd highly encourage everyone to stay active in our Slack community, especially also on Twitter and other channels that Harsh will walk you through later in the presentation. So after we established our community, later on we started offering our first LocalStack Pro services only in July 2020. And in May of last year, we actually founded the company LocalStack. We started hiring until February of this year. We grew our team to over 20 people across 4 different continents, and we're still in a growth journey and still looking to hire. Obviously, we know that the most passionate people we will find obviously within our user base and within our community. So I just want to highlight and encourage everyone to check out our LocalStack jobs page, and also direct people that you know that may be interested in working with us to our job section. We're really looking for people across the board, from engineering to go-to-market to developer relations. So anyone who's interested in the space and maybe a good fit, please feel free to recommend. Yeah, and this year we had our first community event, and now we're really ready to kick things off with V1. We've received some really great feedback already from our customer base. As you can see, some really nice tweets also from Mitchell Hashimoto, the founder of Terraform and HashiCorp, who really was very impressed with our V1 release. And obviously we get a lot of great feedback also from our direct customers. We really work with people across the board, from smaller companies and startups to Fortune 500 companies in leading banks, insurances, media companies, and many, many more. So if you're interested in working with us, also like from a commercial perspective, also, or we're basically very happy to get on a call with you and take all of your requirements. Maybe if we go to the next page. So just a few words about the product tiers that we also released now with the V1. I just want to keep this very short because this session will be focused mainly around the demoing part. But as I said, again, if you're interested in more in-depth discussions about your use case, always feel free to reach out or check out our product tiers page. In general, we've introduced another tier, which is the team tier, that we will go through today a bit more in detail. And we have also changed a bit the packaging. So with LocalStack Pro, you can now basically still focus on the individual developer working on their machine, offering persistence mechanisms for your own basically individual use case. And also a bit of CI usage, so you can already get started with LocalStack in your CI environments and improve out your use case. And as soon as you're really using LocalStack in an organizational setting, in a broader setting with multiple team members, the team plan would definitely make a lot of sense, where we also have all those team collaboration features that we will go through today. And obviously we offer a lot of support also for enterprises if you're looking for dedicated support, if you're having custom use cases, if you need, for example, a special deployment of LocalStack. So all those things we could cover, and happy to discuss in the call more details with you. And that being said, I also want to highlight that, as Harsh mentioned, we also offer basically completely free support of LocalStack Pro for educational purposes. So if you're a student and you're trying to really wrap your head around LocalStack, or if you work for a nonprofit organization and would like to introduce LocalStack, also feel free to reach out to info@localstack.cloud, and we'll be happy to support you, especially also if you're having another open source project that would require the use of LocalStack Pro services. Obviously, we're very happy to support you on your journey. Born in the open source, and we'll always support the open source. And with that, over to Thomas, who will give you some more detailed insights about what's really in the V1 release.
Yeah, thanks, Kato. I'll take over the share because it'll be easier for me. Thanks, Harsh. So I'll talk a bit about releases and how we did releases in the past and how we're going to do releases moving forward. So you saw on Gerta's slide earlier the initial commit around mid-2016. The first tagged release on GitHub was actually a few months afterwards. It was 1.01.16. And there was a period of rapid development where things changed a lot. And actually the first Lambda executed in Docker, which is a huge feature that LocalStack has, was implemented very early on, so early 2017. In early 2019, 1.9 came out. 0.9 came out. There's a long period of not so much releases, where we introduced Lambda hot reloading for the first time, which is also one of the cornerstones of Lambda development in LocalStack. And by 0.10, we had 13 AWS services. There was a big change mid-2020 where 4566 became the standard port. If you're with LocalStack for a longer period of time, then you know that services used to be on individual ports. And now we have this one port to rule them all. Huge change, introduced in one of the patch releases, as you will note. And then with 0.12, we had 21 AWS services. We changed things up as we after we founded the company in 2021, early 2021, things started picking up. We had more engineers to do more groundwork. One of our fundamental changes was this plugin architecture, which enabled service lazy loading. So maybe if you remember, LocalStack used to take about 15 to 20 seconds to start. Now it takes about a second. This is all thanks to this lazy loading architecture. And thanks to Apple, who brought out their M1 chips, we had to support multi-arch natively. So we started building multi-arch images. Big change in 0.13. With 0.14, we started introducing a new framework, ASF, and I'll talk a bit about that. And just now, V1 with 87 AWS services. And as you can see, it took us, 6 years to make a major release. And I want to talk a bit about, as you can see, there's been a bit of a erratic development, which I guess is normal for a V0. And now we're going to release a bit more in a structured way. So I want to just walk you through of what you can expect and how the release process is going to look like. So we are now following semantic versioning, which means that patch releases will go out basically not break your code, and we'll ensure that we'll only push fixes to you in patch releases, and we'll have those every other week. You saw that previously it took several months sometimes for patch releases. Those will be like once or every other week. We consider everything that improves AWS parity a patch. So when we add new functionality to a particular AWS service, then that is considered a parity improvement, and that will be released as a patch. And you will, as I said, see those every other week. And we're introducing things like feature flags to get preview features out in patch releases for you to try. And then minor releases, which will happen every 1 or 2 months, will contain this new functionality. We'll prepare new handcrafted release notes for you, summarizing what's changed in the minor releases. And then major releases will not take 6 years. They will happen once or twice a year. And we have a lot of plans for changing the user-facing configuration, making that easier. We have new behavioral changes, and you'll see with the extensions and the pods that we'll present later on, all of the things that have to change, and we'll roll that out, as I said, once or twice a year. So that is what you can expect moving forward, and just be sure to be on the lookout on GitHub for our GitHub releases. All of that will be published on GitHub on the release pages. All right, and with that, I hand over to Valdemar, who will tell you a bit about what's new in LocalStack.
Thanks a lot, Thomas. If you could just continue.
Yep, sure, no problem. I'll continue.
Awesome, thank you. Yeah, also very warm welcome from my side. It's great to have you all here, and also thanks, Jim, for presenting already. So it's my pleasure to talk a bit about what we've been able to put out with the V1 release, which is really kind of the culmination of like this whole timeline of what Thomas has been showing before, kind of this year-long sort of effort of community work, and also the core team that has been working very hard the last year especially. And this is just a few highlights that we want to pick out and discuss in a bit more detail. So both for the community version and also for the pro version, we've put out a lot of new features and generally enhancements of LocalStack. So first of all, we introduced a new file system hierarchy and just generally have like a lot of ongoing efforts to improve the developer UX. So we want to make it easier for you to configure your system. So in the past, for example, you had to deal with lots of different volume mounts, for example, when it comes to running lambdas and mounting the code into them, or also the data directory for persistence. So it's generally kind of trying to make things more and more easy for you to just get up and running within a second, basically, with LocalStack. We have a full rollout of the AWS Server Framework, ASF. Thomas will share a bit more details about that. It's basically we're continuously using code gen from the API spec, so that's really, really exciting, but more about that later. We're also investing a lot of effort into parity testing for basically making sure that the LocalStack APIs have the same behavior as real AWS. So that's one of the key feedbacks that we also got from the community in the past, and it's also one of the obviously main sources of issues that we see in our GitHub tracker. So we're becoming much more proactive with this new parity testing framework, and I'd recommend and suggest that you check out this blog post, which we released, I think, last week or the week before. So really great read and great work from the team. And also just some new logging improvements and also some more clarity around how persistence works with LocalStack. So that's pretty much some of the highlights for community. And in Pro, we've been able to essentially roll out a whole suite of new features. So one of them is Cloud Pods. We'll actually share a few, like a live demo in a second. So Cloud Pods really is this persistence mechanism that allows you to take a snapshot of your state and share it with your team members. We'll hear about extensions, which is really kind of a new way of extending the platform. So really, our plan is to really open up LocalStack as a platform and kind of make it very easy to plug in new functionality and providers. We revamped the entire multi-account setup. So if you remember in the past, LocalStack was always like a single account system. And now we've actually much improved the experience kind of to create resources in multiple accounts. The same goes for IAM Enforcement, totally rebuilt the entire IAM Enforcement engine, also very exciting. And also generally put a lot of effort into detailed telemetry, giving you insights into how your stacks are being used across your team. So that's just some of the highlights. And if we can please go to the next slide. There's a few migration notes. So generally we try to keep the friction really low for you, so you don't have to sort of deal with issues of upgrading. But there's this article in our discourse forum discussed at LocalStack.cloud. Maybe you can take a look at it. It boils down to a few things that you can change. For example, the network mount in your Docker Compose. Also, you can remove data dir and replace it by persistence equals 1. So you don't need to specify the directory anymore. But it's essentially should be an almost like frictionless upgrade experience from post or pre V1 to V1 and after. But you can check out the details. Okay, so just a brief overview of the multi-account support was what I mentioned before. So in the past, we basically had the single account in LocalStack with all the zeros as account ID. And now what we have is essentially one account state container for basically new accounts that get created on the fly. You can enable this feature by setting multi-accounts equals true in your environment configuration. So it's still sort of experimental, but it's already reached quite a high level of parity, and we're increasingly improving the experience there. So what you can see here in this code snippet in the bottom right, for example, if you run these AWS local commands to create KMS keys, you can create them either in like the first account or in the second account. Currently, we're still using this AWS access key ID as a kind of discriminator for the account ID, but in the next evolution, we'll actually have full integration with STS and IAM to make sure that you have like literally the exact same behavior and experience as in real AWS. So that's one thing. And the second part I want to briefly share is IAM Enforcement. So we did have a kind of an early version of that already pre V1, but it was not as sophisticated and fleshed out as what we have today. So this is now much improved experience. So you can enable this by setting enforce IAM equals 1 in the environment. So as you can see, some of these things are basically behind feature flags or just basically disabled by default, but it's very easy to enable them. And what we can see here, maybe you can just briefly walk through this this snippet here on the in the middle. So this first of all, we create an IAM user. This is this IAM create user command. We can generate access key and secret key IDs for this user. And then when we try to create a Lambda function with this newly created user, it will initially fail because that's expected because that user does not have the permission to create a Lambda function. And then what we do after that is basically creating a user policy that allows and grants access to this create function API call. So this is happening in this part in the, I don't have the mouse pointer, but basically in the code snippet. And then finally, when we run this Lambda create function call again, it actually succeeds and will create the Lambda function because now the policy is successful and has been successfully evaluated. What you also get is very detailed insights into kind of explaining why certain policies and roles apply. So this is kind of highlighted here in this log snippet here. You can see things that are explicitly denied, implicitly denied, or explicitly allowed. So this really gives you a lot of insight into sort of how the API calls are interacting. And it's also doing actually things like composite actions. So create function also happens to require pass role as an additional IAM permission. So that's something we determine basically behind the scenes and the covers. And then we actually also make sure that this permission has been granted and is valid. And the next step for this whole IAM enforcement will be inter-service IAM and also some means to generate policies based on essentially traces of commands that you give us. So lots of exciting stuff happening there in the IAM enforcement area as well. And we'd love to get your feedback on how this can be used and how what your use cases look like. Okay, cool. Over to you again, Thomas, with the tech demos.
Thanks. That's awesome. I really look forward to this IAM stuff. It's not only really cool to have it as a feature, it's also really interesting to implement. So if you're interested in like what's been going on in LocalStack development, reach out to me in the community Slack, and I can give you a bit of insights into the engineering process of these things. All right, so we have two and a half, I would say, tech demos. So 2 tech demos and one just a bit of rambling about ASF. And I'll start talking about LocalStack Extension, which is a new mechanism we introduced in LocalStack v1. There's a GitHub repository that you can find at LocalStack GitHub /LocalStack-extensions. It's highly experimental. We're still developing it. We're still refining the API. Currently, you can install and uninstall some of the extensions that we have provided. I'll show one that we've developed, which includes a Stripe emulation. And we're continuously working on the developer experience, so you can start developing your own extensions. So just a brief explanation of how extensions work and what you can hook into. So this is a basic, really simplified view of sort of one LocalStack instance. So you have your host on the bottom, which just has some AWS client, whether it's an SDK or the AWS CLI, communicating to Docker via the 4566 port. And inside Docker, you have the LocalStack instance running in a Python process. And the principal components are this gateway router, which takes the HTTP requests and passes them to the actual provider implementations. So you'll have one for SQS, you'll have one for SNS, one for Lambda. I'll talk about that later. And we have runtime hooks, which basically execute code as LocalStack goes through the different startup life cycles. So for example, when LocalStack starts up the first time, once all of the infrastructure has been started in the background that make LocalStack work, there's a hook being executed. And now we've placed sort of extension points at these individual components, and you can write extensions, which are just Python programs. There's a very simple API which allow you to sort of extend these points, and LocalStack will execute your program at these extension points. And extensions live on your host, so they are mounted into the container through the LocalStack volume directory, which we've introduced with v1. It's this var lib LocalStack that you'll find. And when you install extensions, LocalStack will install the extensions actually into your host directory, and then extensions live throughout LocalStack runs, so you don't have to install an extension every time LocalStack starts, because LocalStack is in principle ephemeral, so everything is discarded except for what lives in the LocalStack volume directory. Okay, so that is, as I said, we're extending this API, we're improving the documentation. This is really just an experiment to see whether this whole concept works, and whether we can add value on top of the platform that we provide. So I'll give a brief demo just of installing and using extensions. Extensions are currently a pro feature, and I'll install one of our example extensions and show you how you can use it. And the developing new extensions and how the developer experiences will come soon as a screencast. We don't have enough time today to go through all of that. All right, so I'll just spin up my terminal. So LocalStack Extensions, as I said, is a pro feature, so you'll get access to the command once you've logged into to your LocalStack Pro account. So you just type LocalStack login, and then add in your credentials. It'll take a while, and then you'll have access to the extensions command. So as I said, currently there's you need to run init the first time. I've already done that. That initializes the extensions environment on your host, and then you can install extensions in different ways. So an extension, as I said, is just a Python distribution. So I'll show you one example. Basically, a Python distribution comprises a setup config or a setup.py file, which has some basic information about the Python distribution. It has a name, it has an author, and it has requirements, and what's also necessary for building extensions is adding Python entry points. And you can learn all about entry points and how they work in Python setup tools documentation. And we also have our own plugin loading framework, which sits underneath this. But basically, you define a simple extension class. You extend from this class extension, and then you saw these hooks earlier, and you just point the Python entry point to this particular extension, and then LocalStack will be able to pick it up. So this particular extension exposes local Stripe, which is a Stripe emulator. If you don't know Stripe, it's a payment API, so it's a system for you to integrate, so you can perform customer payments. It's also what we use in the background in our LocalStack platform. So we actually developed this for our own needs, because our platform runs on top of LocalStack. So we test our own backend platform on top of LocalStack, and part of that is the Stripe emulation. So you can go to your terminal and just say LocalStack extensions install, and then there's this weird URL here. This gives you a way to install extensions directly from a Git repository. So this gives you also a way to also get started with extensions right away. Looks a bit complicated. It's described in the extension README how that exactly works. So as I said, LocalStack is not running. I'm installing this basically through a container onto my host. So a bare bone LocalStack container starts up, installs the extension on your host, and then it prepares it for execution in LocalStack. And now I can run LocalStack start. And I'll see some weird log output that actually comes from this particular extension. So you can already see there's something going on here, and you can customize things now, like log output, or if you start services in the background, you can completely change the look and feel of LocalStack as well. So this particular extension just starts LocalStripe, which is also a Python application in the background. And what's interesting now, what you can do is you can expose this particular service through routes that are familiar to you when you use LocalStack. So as you know, we have this have this domain localhost.localstack.cloud, which resolves to your local machine. And we use that a lot to sort of make nice URLs for you when you interact with LocalStack so that they look similar to AWS URLs. And now what this extension does, it exposes a host route to 4566 through stripe.localhost.localstack.cloud. So here you're actually, this is actually a curl command against the Stripe API. So this has nothing, the backend has nothing to do with LocalStack. Stripe is just served through LocalStack now. So it's part of your LocalStack instance. All of your LocalStack components can talk to the Stripe API. And let's maybe do something useful. Let's put in some customer data for David Anderson and query that again. Okay, so I'm not going to show you how the Stripe API works. That's not the point of this demo, but you can see that it's very easy now to sort of hook in additional services. And there are lots of use cases for this type of functionality. So we're exploring different use cases right now. One you've just seen, which is just integrating custom service emulators. You can load Python-based initialization scripts. So if you have some complex initialization logic that you need to precede LocalStack with something, you can put that into an extension. One thing that we're doing with Thundra, for example, is this integration, observability integration for CI. You can instrument AWS requests, for example, before they reach your Lambdas. You can intercept AWS requests for logging or auditing, and really whatever you can come up with. So you'll see us providing more and more extensions just to demonstrate how you can use them. We'll add some value add extensions that will be valuable out of the box. But really, this is for the community to explore and develop. And as I said, I'll post a screencast in the upcoming weeks about how you can start developing extensions yourself. Okay, that wraps up my demo, and I'll hand over to Valdemar now.
Thanks a lot, Thomas.
Do you want me to continue sharing for you, or?
No, that's fine. I can take over the share. Thanks for that. All right. So this next thing we want to briefly, first of all, extensions is really great. So thanks for sharing this, Thomas. I think it's a great way to highlight how we're opening up LocalStack really as a kind of platform and enabling additional service plugins, but also value add services within the existing ecosystem of services. So we're, for example, working on one thing that's one extension that allows you to replicate resources from a real AWS account into your local instance. So there's lots of extensibility points that we can plug into here, basically. So what I'm going to show here real quick now is going to our slide deck. Yep. Onto where's the demo part? Extensions. Yeah. So briefly talking about CloudPods. So CloudPods really is this team collaboration feature that we've been working on, especially leading up to V1. And just to give like a bit of context, in general, like the state within LocalStack is ephemeral, right? So when you start up an instance and you tear it down again, basically the state is gone because we keep things in memory. But there is also ways to actually sort of take a snapshot of the state in your instance. So CloudPods really is a way to take a snapshot of the current state of your container of LocalStack and then store it either on disk or on a backend storage. And then you can do things like essentially creating multiple versions of a CloudPod and very easily also share it out with your team members. So it's really a way to store the state and also enable things like collaborative debugging, as we call it, when we want to share maybe the state of your application and ask a team member for help. Hey, can I just share the state with you so we can take a look at that as well. Just a brief word on sort of how CloudPods compare to persistence. So on the left-hand side, we can see persistence, where essentially whenever the client is making requests to LocalStack, we just continuously store the state to disk. And then when LocalStack sort of stops and starts up again, we reload the entire state from the persistent storage again, and basically you have the same experience and the same application state as before. With CloudPods, it's a bit different. So here the assumption is that you can actually work with a running instance, and you can in a very similar fashion to how you would interact with Git objects, you can basically take a commit of the current states. You can inject it again. That's kind of the reverse operation of a commit. So those are all kind of for the local interactions. And then you can also do push and pull operations, which are, again, similar to Git. If you push your changes to a remote, and then someone else can pull down the changes that you've been working on locally. So what I'm gonna do real quick is just go through some creating some state in LocalStack and basically really take a commit and create a cloud pod. You can then also inspect the state, then restart the instance, inject the state again, and then maybe at the end also briefly show how this push and pull works also with the UI extension that we have. Okay, so I'm gonna switch over here, and first of all, gonna start up LocalStack. So if you can, it's a bit busy my terminal here, lots of different output. You'll also see that this is debug output enabled, so you'll see lots of logs here. And now what we're going to do is basically just create a bunch of states, right? So basically create, I don't know, an SQS queue, and then Q1, the second one, named Q2. And then basically, you know, this is just the regular way how you interact with LocalStack in the most general way. Now what we have is this new API, CLI command in LocalStack, which is called pod. And what we can do here, first of all, is we can do a list. So you can list all the pods that are currently available locally and also remotely. In order to do the remote operation, you'll actually have to be logged in. So there's also a login command. And you can see I've been creating a bunch of like different pods here ready to play around with this in the past. And what we want to do now is basically commit the state to a new pod that we're going to call, so first we're going to delete, make sure that it doesn't exist. I'm going to delete pod 1. And then we can create, commit this state into a pod called pod 1. Okay, now it says successfully state. So basically now these two SQS queues that we created before have basically now been created in LocalStack, right? So this is kind of the creation of a pod, and now it's been stored on the local machine, and it can then sort of be versioned and also kind of inspected as well. So let me just briefly take a look at the inspect command here. So inspect is pretty simple. It just basically gives you in this terminal view, it's just a terminal where you can see the queue URLs that we've created before. So fairly simple just to interact and see what's the content of this pod. Okay, now we can create some more state also. Just gonna scroll down here a bit. You can, for example, also create an IAM user. Has been created. We can do another commit. So basically commits build on top of each other. We can basically create these multiple versions and commits. And then I guess the interesting part is now that we actually have this pod stored, we can restart the instance and then inject the state back in again. So I'm gonna just restart LocalStack, starting from a fresh state. And we should, if you now list the queues here, it's gonna be empty, right? So there's currently no queues. And what we can do now is basically inject the pod states. So now, after we've done this, if we do another list of the queues, we should be able to actually see and interact with the queues that were created beforehand. So it's a fairly simple example here, but you can imagine how sort of we can spin this further in terms of predefining certain states, making it available to your team members, and then also sort of pushing and pulling the state to the backend server. And in order to briefly demonstrate that part, I'd like to switch over to our web UI. So this is app.localstack.cloud, which some of you may be familiar with. So you can create an account there and just have this web UI. And what we can see here is this cloud pods view. It's a fairly simple just list of pods that have been pushed to my account already that we've prepared for this demo. And what we want to do now is actually inject one of these pods into the local machine. So we can take a quick look at what this pod looks like. So this test pod here that we've prepared before, it's actually a bit more complex, has some AppSync, GraphQL APIs, it has some Kafka cluster, it has a Lambda function, it has an SQS queue, and a bunch of more resources basically. And what we can do now is we can inject or pull down this test pod into our local machine. So what I'm going to do is LocalStack pod pull, and then specify as the pod name this test pod. Again, what this will require is a login. So I think I still have an active session here, so I'm already logged in. And now what actually is happening, you can see here on the left-hand side is a bunch of services are basically now restarting. The state is being injected, and we can basically see that this pod is now being injected into the local instance. So for example, we can do, we can list the Lambda functions. I think I have a Lambda command here in my history. So the Lambda function has been created. I think there's also this Kafka, can list the clusters. There's this AppSync, it was local AppSync list GraphQL guides. Right, so you can basically see that this entire state has now been injected, and it's very easy to interact with it and also make changes, push them again to the server, and make them available to your team members. So this is really kind of a first starting point for pods. We're sort of also expanding a lot into how you can use this in a CI context and use it in different kind of scenarios. But this is really just to give you a bit of an idea how you can use it, and we'd love to get your feedback in terms of different user scenarios and how you envision this could benefit your team collaboration patterns in your company, in your organizations. Okay, I think with that, there was the Cloud Pods part. Handing over again to Thomas for ASF.
Yeah, thanks, Waldemar. This is really blazing through the content. There's lots more to talk about Cloud Pods, and there'll be much more to come. And you can try out Cloud Pods if you aren't a pro user yet. You get a free trial and play around with it. So I want to spend a few minutes talk about a bit what's going on the community side of LocalStack. So you've heard a couple of times maybe the phrase ASF, the AWS Service Framework. One thing we built this for is obviously to increase parity with AWS, and I'll explain in a second how we did that. But it's also making it a lot easier to contribute to LocalStack, and I'll walk you through that. So first of all, the AWS Service Framework and how we're building stuff on top of that is outlined in this blog post that was also mentioned earlier that we wrote, where we explain how LocalStack keeps up with AWS and how we ensure parity. So one big part of AWS parity is obviously protocol marshalling. So when an HTTP request comes into LocalStack, that we interpret that HTTP request correctly and then forward it to the correct service with the correct parameters and so forth. So that used to be done very differently than it is now. We now build ASF builds on the official specifications of AWS. So if you're active in the AWS developer space, you've maybe heard of Smithy, which is a specification language that AWS has been driving, and all of their APIs are available as JSON or Smithy specification documents. This is an example of Amazon SNS, which is this publish-subscribe system. So in a pub sub system, you have topics, and SNS provides one operation to create a topic, and you can see this outlined here. So the actual input shape is defined elsewhere, which contains all of the parameters. But basically what we can do now with these specifications is we've built our own code generation tool, which generates server-side stubs for this in LocalStack. So you will find in the LocalStack code base these auto-generated API stubs in Python that we then extend on. And we're using official AWS tools. So this is nothing handcrafted from LocalStack, which it used to be. We used to do protocol parsing all by ourselves and dispatching to particular implementations. This is all based on official specs now. And you can see in this blog post, we outline that how we leverage that now also to keep up with churn in the AWS APIs. So here's just a screenshot from a GitHub action that we built that runs every week on Monday. It regenerates all of the API stubs and makes a pull request. And on the right-hand side, you can actually see the diff. So in this case, it's Redshift. There was some operation introduced. You can see the get cluster credentials with IAM was a new operation, and we get a pull request and we get informed by that. So this gives us a great way to jump on new features. This also gives, if you're interested in contributing to the community repository, also a way for you to jump on things. So if you see something being introduced in one of these ASF pull requests, feel free to jump on implementing that feature, and I'll show you now how you can find the code where you actually have to do that. So as I said, we have these generated API stubs that live in the LocalStack repository. You can find that in LocalStack/AWS/API and then the service name. And we implement those APIs in LocalStack services and then the service name /provider-pi. So that contains all of the implementation for this one particular provider. And we basically just inherit from that and implement this API. And the little bit that I highlighted is the emulator code. Actually, there's lots more. Obviously, this is where the magic happens. And these implementations often use some type of backend. So this is just sort of the code that interprets the API call, and then we have some backend doing the actual emulation. So some services like SQS, for example, use only LocalStack code. So we've revamped SQS completely. It uses only LocalStack code. There are no additional backends. A lot of our services use Emoto, which is a fantastic open source library, also in the AWS tooling space, and we use that as sort of a storage backend for a lot of our services. SNS is an example. And we build on other great open source technologies. So RDS uses Postgres, for example. Elasticsearch uses the official Elasticsearch binaries. And these implementations basically manage their own backend state. So if you're interested in looking into one of those services, helping with particular implementations, fixing bugs, the little bit down here is where you have to go. Right. So, and this is a good segue, I think, into the LocalStack community, which Harsh will be talking about.
Thanks, Thomas. Can I take over the sharing?
Sure.
Cool. I guess my screen should be visible right now. So apart from all of the technical and the engineering stuff, we have also been doing a lot of community related stuff. And one of the first things that we have done is to make the whole developer experience much easier. So over the past few months, we had almost over a dozen new contributors who are coming and contribute to various LocalStack projects. These are mainly upon the LocalStack core code base, the documentation, and even some of the other utils and libraries that we are maintaining for the sake of the developer experience that we are building around LocalStack. Apart from this, we have also initiated our discussion pages. So for people who are not familiar with what discussion pages is, then it's our self-hosted discourse. Sorry, not self-hosted, it's a managed discourse instance that we are having. And this is what we're exactly using for maintaining our forum. So over the past few months, we have realized that a lot of our Slack conversations are just getting lost due to the free tier that we are on. And we needed a more consistent way to make sure that all of the conversations that were happening is actually well maintained. It should be searchable and it can be indexed upon the Google search, which most of the people are using. And that was our primary rationale behind initiating this particular community forum. We have also gamified this forum, so people who will be posting more upon this forum, like we'll reach out to them like with some interesting stuff, maybe swags, maybe something else. And it is a really nice place to connect with the community. Maybe share your findings, share your experience about LocalStack, and also share some tips and tricks that you might be using while using LocalStack. So if you have not used the Discuss forum before, you can just navigate to discuss.localstack.cloud, and that would be a great place to get started with. If you want to create a post, you can just go and click upon a new topic, and this will help you get started with a post. So you can just share whatever title of your post is. You can select if it is a platform related post, if it is a site feedback, if it is a feature request, or else if you have a particular LocalStack workflow, some best practices that you must be using, you can just use that. You can put up all of the tags that you have on the mind, and you can just use a standard markdown to write down the content and just post it over here. And we would greatly appreciate any sort of contributions that are coming in. And the discussion pages are built in such a way to differentiate from the regular bug reports that are coming over the GitHub issues and the Slack conversation. But we definitely have no problems with people posting bug reports over here, and we just greatly appreciate all of them. In the future, moving forward, the engineers who are working with LocalStack, they will be actively using discussion pages to just communicate all sort of new features, enhancements, bug fixes that has been done in a particular AWS service. And for major features in any upcoming major release, we might also be using community feedback to decide whether we want to pursue it or not. So we have a lot of these features in the pipeline, and we would definitely appreciate all of the contributions coming in. If you want to join our Slack channel, you can just scan this QR code and you can just get started with it. Previously, our Slack community was just closed and people needed to privately request us for a joining link. But right now we have just opened it for nearly everyone. So anyone can just go to our localstack.cloud contact page and they can just check out the Slack link that is present over here. And if you want to avail the education license, we have the education license page over here. And the only criteria is that you should be enrolled in a particular university or college or a school as an educator or as a student. And we would be happy to support you with a 6 months of free education license for using LocalStack Pro. So coming to some good old stats, over the past few years, you can actually see on how many PRs that we're actually merging in the LocalStack code base. Most of these PRs are coming from the engineers who are working with us full-time or in a freelance manner. But some of these PRs are coming from the community contributors. So if you're considering to contribute to LocalStack, it is definitely the best time to do right now, because we have a lot of bugs, we have a lot of feature requests, we have a lot of enhancements that are coming up. And with the improvement of the developer experience using ASF and the other toolings, it is definitely the best thing to do right now. So just navigate to LocalStack's community code base, and you can check out all of the open issues that we have present over here. To make the navigation part easier, you can just go to the LocalStack community code base. You can check out the issues, and you can actually just go through the labels and see what part you want to work on. Perhaps the best way to get started is to actually look upon all the issues that have this triage needed status, because we have not actually validated if it is a bug or it is just a regression in any past version. So we would definitely appreciate any help if you can help us triage these issues and help us maintain our backlog overall. We have also been getting a lot of issues. Most of these issues are around bug reports, enhancements, feature requests. And lately we have been closing a lot of these issues. Some of these were related to some past version, which must have been fixed. But if you can just chime in and you can just get started with triaging those issues, helping us validate if this issue is still a pending one, that would be definitely appreciated. And if you're looking for a particular AWS service where you can help, maybe you have the expertise and maybe you have the experience to provide the best help around that, you can just go upon the issues per service. You can check out all of the services that we have and the issues that we have open over there so that you can help us in the best manner possible. So over the next coming months, we will be trying to expand the LocalStack community more and to support more open source contributors to get started with us. And we'll be happy to provide any sort of mentorship or guidance or any other help that you need to make your first good contribution, which we will obviously be celebrating with you. So this brings us to the closing part of this session. So thanks all for chiming in and being a part of this session throughout. We had a comparatively less number of audience, but everyone nearly stuck with us till the end. So greatly appreciate your time and your patience. And now is the Q&A effort. So you can just go to the slido.com. You can maybe scan this QR code, or maybe you can just join slido.com with this particular code, and you can start asking all your questions. If for some reason you're not able to access Slido, you can just use the Google Meet chat and you can put all your questions forward.
Thanks.
So we have a good question here.
Great.
Integrating local stacks with Jenkins.
Yeah, I'm wondering whether this relates to the still the drone CI talk or the extensions demo. I'm sure there are cases there. I mean, we can basically integrate with any CI environment. If you're using
I can share a status on this. We actually have the documentation ready for LocalStack with Jenkins. One of the engineers, his name is Dominic, who is working with us. He has added the documentation. We are just yet to merge it and just release it, which we will do just in this week itself. So, yeah.
Any more questions, feedback? We're rushing through the demos. That's why we're actually
yeah, we have some time now. Valdemar, do you want to tease us a bit with what's coming up with pods? What are some things that we can expect there? Some development.
Yeah, definitely. So I think with pods, I mean, it's really like kind of a basic foundational technology that will allow us to do things. So we have a couple of things in mind. For example, opening up like a registry of pods where you can actually pre-select different kind of predefined states, and also do things like composite pods. So basically, if you have two or a multitude of multiple pods defined, you can actually inject sort of a union of all the states of those. And it's also something that's very sort of helpful. We're actually starting to use that also in our own pipelines for CI context. So let's assume you have a red build in your pipeline, and at the end you want to understand what was the state, why do I have a red build in my CI pipeline, and then you can actually pull down that state with a cloud pod and get some very detailed insights into kind of the content of the pod as it was failing. So we have, and that combined with the ASF and the API specs that Thomas was sharing, gives us a lot of 360 degrees overview of kind of how you're using your instance, both from the API request perspective, but also the internal state of your instance. And that's an enabler for quite a few exciting extensions there.
A few questions coming in the chat. Harsh, you maybe want to pick those up?
Sure. So one of the questions is from Vijay. Is there a multi-cloud approach in the roadmap? Maybe Voldemort, you can answer this.
It is for sure. So we haven't sort of committed to publicly sharing that yet. We are now really sort of building the foundation for going into sort of targeting the next cloud provider, which will be Azure most likely in the course of the year. And again, we've had a very exciting learning experience and learning journey in the last couple of months. So I think we know a lot about things, how to emulate cloud APIs, how to test them properly, how to do these things like specifications and code gen. And this will enable us to move very quickly in the Azure space. And if you have some specific use cases, please reach out to us. We'll be happy to address those.
The other question is by Saurabh. I guess I can take it up. Any updates on attaching debugger and adding breakpoints to JavaScript Lambda code? Maybe VS Code how to tutorial. So Saurabh, we have added a documentation this week, I suppose, to basically hot reload your JavaScript Lambda functions. I guess I'm just working upon the documentation for attaching a debugger and just working it through on the VS Code right now. So maybe by the next week itself, you will be able to find the documentation on the official documentation site, which is docs.localstack.cloud. I'll reach out to you personally if you're on Slack to just let you know if it is ready.
I love the question. Next one, maybe Thomas, you can take that one.
Yeah, sure. So we've changed the way the Docker image is built several times throughout history, and the effort to reduce, we had to introduce some changes that just increased the Docker image size. And now we're really tackling to get that down again. All of this extensions and plugin mechanisms that you saw will be an enabler for that. So we will be able to ship a very slim image to you, and all of the libraries that you need will be downloaded on demand. In most cases, you probably don't even need them. So maybe if you're not using OpenSearch, you don't need a Docker image shipped with OpenSearch. So that's what we're addressing. So that's one aspect. And the other aspect is we're exploring different technologies to just make the image smaller. So it's definitely on our roadmap, and you can see some significant improvements over the next months.
Yeah, especially also relevant with the 100 million Docker pools that we celebrated literally today. So if you check out the Docker Hub, we're aware that the size of the image is obviously something that is very important to us, and we want to keep that down. Cool. Any more questions?
I guess we have no questions now, so maybe we can close this out.
All right.
Awesome. Thanks everyone for joining in, and we hope to see you again in the next community meetup. If you have any further questions or concerns, maybe just reach out to us on the community Slack, and we'll definitely be quite happy to support you in all your endeavors.
Thanks, folks. Have a nice day.
Have a great day, everyone.
Bye.
Thank you.
Thank you all. Have a great day.